Welcome everyone. I am Pushkar. I am a tech lead at GeekyAnts. As Rishabh mentioned, there are a lot of exciting things happening in the Flutter space. Things like decentralized applications and Web3. And then Flutter also went into stable web last year. And one of the reasons I selected this particular topic, Flutter Navigator 2.0, was because once Flutter went into the web stable, a lot of people started exploring the web development. And one of the initial blockers or bottlenecks that everyone encountered was basically the web behavior, right? So, I mean, the web would not feel like web, and especially with respect to navigation, the Navigator 1.0 that we already had was not good enough to cater all the cases, because you would not want screens to be pushed and popped when you're using say a web application, right? So that's why Flutter team came up with Navigator 2.0. But in my experience, this has been one of the most controversial APIs that I have ever worked with, right? I mean, people were they were open GitHub threads that where people were complaining that this is too difficult to understand. And there were like a lot of people who just gave up on Navigator 2.0. And at the same time, I, as a tech lead, started exploring Navigator 2.0, understanding what exactly is the purpose behind which the Flutter team has created this API. And once I started exploring it, I realized that it is more Flutterish than what Navigator 1.0 would provide. So what I will do today is basically I will be explaining how the Navigator 2.0 works. Also, what we'll do is we'll have a very basic application where we'll have a public route and a protected route, and then within that protected route we'll have subroutes. So it is typically inspired by, say, how Twitter functions. So you log in, go into the home page, and then you can switch in between the profile settings and notification and other sub routes, right? So we'll try to create something like that. And also I will be sharing a very extensive Flutter web project that we are working on. It's again a game which is based on blockchain, but it needs Flutter Navigator 2.0 very, very extensively. So let's get started. So the first question is like, why Navigator 2.0? Why did the Flutter team introduce Navigator 2.0 when we already have the Navigator 1.0, right? So one of the main reason behind that was that Navigator 1.0 is more of like an imperative API, whereas the Navigator 2.0 is a declarative one. Now, what is the difference between an imperative and a declarative would be? In the case of an imperative, we basically go ahead and define, say, a set of code and a set of instruction, and we say, okay, the 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 computer has to go ahead and basically execute it in sequence, right? Whereas, as the name suggests, the declarative API, what the benefit of having a declarative API is, basically we define and we declare what exactly we need, and then we process that information out of some result, right? So that's what the declarative API would is. And Navigator 2.0 is also based on the declarative API. One of the main reasons for that was that it had to support the web navigations, right? Because when we are using having a mobile application, we control what is to be pushed and what is to be popped, but that doesn't work in web, because a user can go ahead and can manipulate the params that we have in the URL. And also uh, there are more complications comes into web, like a web browser history and whatnot, right? So declarative API, and as I mentioned, that because of the declaration, we have like clear separation of concerns, and we can make decision making at a time when we are processing those information. And again, one of the other advantages is that like for deep linking, like suppose if you have to land users into a particular page when you are routed to the application from any of the external browsers. So that is also one place where the Navigator 2.0 really comes into handy. So what we'll do is we'll first understand its key concepts, right? I will not go into a detail and explaining all the classes that it has, but the key concept of how exactly it works. So what I would like to emphasize on is basically three important parts, right? One is the operating system, which can be a mobile or which can be a web, right? Now, in mobile and the web, the routing basically works different, but what you have to understand is that one important say stakeholder here is the operating system, and then there are two important classes. One is the router delegate and the router. Now this router is a special type of a class that was introduced with navigation 2.0 to cater all these declarative form of routing that we will be encountering right now. So I mean, just to go through the flow, so we'll have an operating system, and then what happens is this operating system basically provides information to the route information provider. I mean, we route information provider might not be a very important concept here. We can directly skip to the information parser, but what it does is that once your app is getting booted, you either get a initial route or you get a new intent, right? And the route information parser, what it does is it takes that information, and basically as the name suggests, parser, right? So it takes that information and parses that. So what it means by parsing is that it gets an information, say a route like a product, and say slash id is equal to something, right? So the route information parser is the class where we take the routes and then we parse it based on whatever the URL we have got. After parsing, what happens is that the route delegate takes that information in, and then it has basically three override methods that we'll just discuss. And it basically what it does is that through the navigator class, it tries to create a history of all the stacks and the substacks within a stack, and cater to our browser history as far as the web part is concerned. And then there's a router class, which is again at the material level. So every time, suppose if there is a change in the router delegate, the app states gets updated, or we change the router through an intent in the app, and then the router gets rebuilt, it gets configured, and again the app state changes. So this is like the overall main concept that we have. So what we'll do is we'll basically look into a working example. So it's a very simple example. One is that we'll have a public route, which is login. Obviously, login is for everyone. And then after login, we'll have a home screen. And then within that home screen, we'll have things like profile, settings, more, not found, and then there will be like further sub routes, right? So more slash something, and we need to cater on those informations as well. So let's go quickly to the code. As I mentioned, we'll primarily have two screens. One is the login screen and the home screen. So there is nothing very specific as far as the screens are concerned. It's just like one is the login screen and the home screen. So what we'll focus more on would be the route methods, right? So what we'll do is we'll start from the app.dart, and there, as I mentioned, the first class comes into picture. So instead of directly using the material app, what we do is we use material app.router, right? So what it does is this router is basically the first layer of information that we'll have. So router basically has a lot of extended props within it, where it gives a lot of flexibility, but what we will focus primarily would be on router delegate and the route information parser. Now, if we'll go back to the previous key concept diagram, you see as the app is being booted, we get the route information, and then we basically pass that information. And that's exactly what the route information parser is going to do for us, right? So this is the first class that we have. Here, as it mentions that this custom class basically extends to the route information parser itself, which basically takes a generic type T, which is the route path. Now, route path is nothing but basically the route strategy that we'll have. It defines the path structure for us, right? So what we need in the route path is basically a path name, and whether or not that path is known to us. So suppose if a path is not known to us, then what exactly we are going to do in that case. So this is particularly the method where it takes that parse information route, it takes that information, and then based on your business use case, it goes ahead and it parses that, right? And what it does is, after parsing, it refines that information and creates a path name, right? And this is where the router delegate is coming into picture, right? So let's go to the router delegate then. What router delegate does is basically it takes the information, right? And then basically it has that responsibility of setting in not just the initial route, but also uh, any further routes that we'll have. That is also what the router delegate will be doing, right? So within that router delegate, we have lot of different type of override methods. What majorly we are concerned about is the current configuration, and the other one is the set new route path. So the current configuration, what it does is that it takes that configuration and analyze whether or not this particular set of route, whatever route we have got, is it a valid route or not. And then the set new route path, as it suggests, that it takes that information and sets the route in that navigator class that we have. So navigator class is nothing but basically it takes that it keeps track of all the routes that we'll have and maintain a stack based history of the child widgets, right? So this is overall what we have. And then there are other like subclasses as well, such as like a back button dispatcher and a transition delegate. But those are basically a part of the app router delegate itself, right? So we have a transition delegate class as well, but it isn't as specific that we have. So what we have right now is a basically login screen. So let me take you to the application. So this is what our web would look like. So we'll have a very simple login. So we'll go ahead and maybe like I will enter my name and then the password. And what it will happen is when I log in, then it will take me to the home screen. Now this is a dummy screen that I have created basically in order to cater the sub navigation. So by default, we land onto the home page. And then if I click on the profile, so it takes you to the profile settings and the more. But not only it does that, it is also ensuring that it does not have that push and the pop effect that we usually have in the Navigator 1.0, right? So, and the another important part, which is basically the browser history. So suppose if I am on more and I go to the home, and if I click back, I again come into the more screen, right? So it ensures that our entire uh, browser history is maintained, but also at the same time ensuring that we do not have unnecessary transition rebuilding the pages again and again. Not only it does that, but also through the route handler that we have created, we have clearly defined on the different route structures. So in our case, we'll have a not found where we do not know what route. Basically, it's an unknown route, and then we have basically the known routes, and then we have a basic singleton class called as a route handler, which takes the route, and then based on whatever the information we get, they go ahead and they render that information out, right? So basically, based on profile, it is going to re-render, like render the profile widget, and similarly, based on settings, it will do that. Now, let's look into whether or not it will directly land me onto the settings screen, right? So if I go ahead, since I am already a logged in user, so what it will do is it will directly take me, it will take that decision. So basically, that decision of basically checking whether to take them to the public route or the private route will be done by the router delegate itself. So it took me directly to the settings screen, and then I can simply go back and there is no browser history at all. So this is one of the extended features. Also, another important point is, suppose what happens if the user goes ahead and try to go into the login screen, right? Ideally, it should not take us to the login screen. So, but if I go ahead and click it, it will ensure that it does not take the user to the login screen. Why? Because I am already a logged in user. So what it did is by default, it is taking user to the home screen, and that is what you expect it to be like. Another point is, suppose if I log out and then if I want to go ahead with the home screen, should it take you to the home screen? It won't, right? Because again, the router delegate took that decision that the user is not authenticated yet, and we cannot set on the route to home, rather take user to the login screen, right? So this is where the advantages of the Navigator 2.0 comes into picture, because since it's a declarative style of an API, we can basically have a declaration and then process that information at a time when we have to, right? So here, based on our declaration, we have a clause that if I am logged in, I can't go into the inner side of the application. So yeah, so this is the one. Other than that, I also wanted to share one very extensive project that we are doing internally. It's a blockchain based game, completely made in Flutter, and it is potentially one of the most complex web projects out there in the market. So let's go through that particular app as well. I will also share that link, so you can go ahead, you can test those application and have a proper feedback around that. So this is basically a blockchain game completely made out of Flutter, and it's basically the game is called as a soccer manager. So it's basically you can go ahead, you can trade players in and out. But what it does is it handles and it uses Web Navigator 2.0 very extensively, to an extent that I can directly go to a particular club. So, for example, Club 77. So, what I want to do is basically I want to see the information here about the Club 77, right? So, I can directly land in here. Also, we have shareable links, right? So, not only we have the basic application where everything is basically a shareable link. For example, this player, or this isn't a player, but this is a club. So, let's go to maybe a player. So a player called as, say, this. Now this is basically a shareable link, so I can basically, through the declarative style of the Navigator 2.0, I can take the decision of how and where take the users in. So here in this case I directly landed into the player screen, and similarly the sub navigation as we usually have, the matches, the league table, and with the game world. And if I go back, I can directly land into the matches, right? So it's currently under development, but it's a blockchain-based decentralized app for basically the. It is based out on the Ethereum network. So do check this out as well. Other than that, I have also updated important resource link. I have already open sourced the Navigator 2.0 project that we just discussed here. So you can go ahead, you can check that out and do share your feedback. Other than that, I've also updated the app link, and there's some important links that I basically took as a reference in order to, go through the Navigator 2.0 and understand the concepts. So you can check that out. Thank you. That's it from my side.